1.4 complex number preparation. Okay, so we're going to choose all of polynomial written descending powers and not a polynomial descriptions that apply for each of the following expressions. So polynomials, it's the easiest way that I know to explain what a polynomial is to show you what is not a polynomial. Okay, so polynomials. Okay, so it's not a polynomial if the exponent is a fraction. That's not a polynomial. It's not a polynomial if the exponent is negative, right? And it's also not a polynomial if you see variables in the denominator, right? So if it's in the denominator like this, that is also not a polynomial. Now later on we'll learn that these last two are actually the same kind of concept repeated, because negative exponents, whenever you write it without the negative exponents, it's going to end up on the bottom. And we'll go over that later. Okay, so there's also something called monomial. We have binomial. We have trinomial. Okay, and then we have the normal, we just say polynomial. Now, kind of want to remove some ambiguity here. Monomial is a specific type of polynomial, but with one term. Binomial is a specific type of polynomial with two terms. Trinomial is a specific type of polynomial with three terms, but they are all polynomials, right? So all of these are underneath the category of polynomial, okay? So monomial is still a polynomial, binomial is still a polynomial, trinomial is still a polynomial, but usually whenever we go above 3, we usually refer to them just as polynomials at that point. Okay, so we want to choose all polynomials written descending powers, and not a polynomials. Okay, so first of all, polynomial has a 5, 2, it has an understood or implied 1, and then there's a constant which understood power of 0. Now, so we would say that this is a polynomial. Now, is it written in descending powers? Okay, well, 5 is the exponent, then 2, then 1, and then 0. So we can see that the leading exponent and then every exponent after there is going in descending order. So this is actually written in descending powers and not a polynomial, although this is a polynomial. Okay, so we could say this is a polynomial. Polynomial. We would also say it is written in descending. Descending. Okay. Now, how about this one? Okay, so first of all, we see that we have a 4 and a 6 exponent. So not a fraction, not negative, not in the denominator. So this is, in fact, a polynomial. And specifically, we were going to call this one a binomial. And it's still a polynomial, but because it has two terms, we're going to call it a binomial. Okay. Now, is it in descending order? No. In fact, this one is not in descending order because it starts with a 4th power. And then the next one is a 6th power. So we are going to rewrite it in descending power. So we're going to write this as p to the 6th plus 2p to the 4th. So now the first term is a 6th power and the second term is a 4th power. All right, so let's try the next one. Now notice that this one has a variable in the denominator. Now since it has a variable in the denominator, this is not a polynomial. Not polynomial. Sorry about my handwriting. Okay, now at this point, it doesn't really matter whether you write in descending order or not, because it's not a polynomial. It's just that generally speaking, the correct way to write polynomials is in descending powers. And we'll get into kind of why that is later. Okay, now let's look at the last one. Now this has an understood or implied 1 exponent there. If you don't see it, has a 1. And the last one, if it's a constant, has a 0 exponent, understood 0 exponent. Okay, so what we would say is, since there's a 1 exponent, there's no fraction, there's no negative, we would say, yes, this is a polynomial. In fact, since there are two terms, we would call this a binomial. And because it is first power and then a constant, that's 0 power, it is in descending order already. So this is already descending. All right. Hopefully that makes sense. Let's do some more practice on this. We're just getting some terminology down. Now, we don't test you directly on terminology, but you need to know enough terminology that whenever a question asks you a question using that terminology, you have to be familiar enough with the terminology to be able to answer the question. There are many students that struggle with answering questions because of the terminology and not because of the math, so to speak. Okay, now the best way that I know for you to get good enough familiar enough with the terminology to do well is every time they ask you a question, actually read the question. I know and I'm guilty of this as well, is that once you get the pattern down, it's very easy to skip the question and stop reading and getting familiar with the terminology. But if you just take those few extra seconds, every question, read the question, read the terminology. And generally speaking, that'll get you familiar enough with the terminology that you can do well. That's good enough, generally speaking. Okay. So again, make sure you take the extra time to read the terminology so that you're familiar enough with it that you can answer questions. Otherwise, you might get in a situation where after you get it wrong, you look back at what you were supposed to do, the correct answer, and you go, oh, I knew how to do that. That was so easy. But you got it wrong because you didn't understand the terminology. So we don't want to make that mistake. Okay, so first of all, term. So terms are separated by addition, subtraction, or even the equal sign. Coefficients are the numbers in front of the variables, right? So this right here, we would say the coefficient on this one right here is the 3. So we would say it's a 3. Degree is the power or exponent, right? So in this case, the degree on this one is a 4. Okay, so let's go on to the next one. So we have 5x or 5x to the first power. Again, if you don't see the exponent, you understand or it's implied 1 there. So we would say, see, the coefficient is the number in front of the variable, that coefficient right there. So that's a 5. And we say the degree is 1. Now just remember, even if you don't see it, it's still a 1, right? So if you don't see the exponent of the variable, it's understood or implied to be a 1. Okay, so let's try the next one. So we have a negative 7 or negative 7x to the 0th power. And this is what I was referring to earlier when I said that if you don't see the variable, it's understood to be a 0th degree or 0 power. And the reason is if I take an x to a 0th power, right? So for instance, and you don't have to know this explanation, you can just memorize that constants have a power of 0. But this is kind of the algebraic explanation of that, right? So you could say x to the 0th power is 1. Negative 7 times 1 is negative 7, right? But you can see that because the power is a 1, it just goes away. And this whole thing turns into a 1, and then anything times 1 is the other thing, right? So, anyways, you don't have to know the explanation, but you do need to know that if you see a constant, the degree is a 0. Okay, so we're going to say the coefficient here is negative 7, and the degree is 0. All right, let's move on to the next one. So we say 2x squared y, or 2x squared y to this first. And all they're saying here is that if you don't see the degree is understood to be a 1. Now, this is a little bit different. Whenever you just have one variable to a power, you understand that it is to the first power. If you have multiple factors being multiplied together, though, what you have to do is you have to add the exponents together, right? And 2 plus 1 is a 3, right? Okay, so this is a little bit different because these are being multiplied together. You add the exponents together. And again, so 1 plus, I can put it right here, 1 plus 2 is 3, right? Okay, oh, sorry, that's the degree. My bad. Got a little overzealous. Let's fix that. Okay. Now, the coefficient on this is still going to be the 2. Just like that. Okay, so move on to the next one. So coefficient is a 12. So we put that 12 here. The variable is, the degree is a 9. So we put the 9 there. We have 3x to the first power. So the coefficient is a 3. The x has a 1 degree. We have negative 6. So the coefficient is a negative 6. We keep the negative. And the degree is a 0. Again, if you just see a constant, the degree is automatically 0. We already explained why. Let's try these. These are actual polynomials, though. Okay, so let's instead do a leading coefficient on this. So if it's in descending order, if it's in the proper order, the leading coefficient is just going to be the one with the highest power, because that's the one that's going to be first. So the leading coefficient on this one would be something like a 3. So you can do leading coefficient here. The degree of this entire thing is going to be the degree of, again, it's the leading term if it's written in descending order, or just the highest degree of all the terms. So in this case, it's going to be a 4. Okay, so we have 5x. Leading coefficient is a 5. The degree is a 1, because there's understood or implied 1 there. We have x to the 5th. We have an x to the 6th. So in this case, the 6 is the higher, so the degree is 6. And the coefficient here is a 3, so we're going to do a 3 there. We have 1 and 1 there, so that's actually you add those together, so that's a second degree term. We have a 2 here as well. And over here in the last one, we actually have 2 plus 1, which is 3. So we would say that's a third degree polynomial. We would also say that the coefficient in front of that is a2. The leading coefficient is a2. Over here we have a negative understood negative 1. There's a fourth degree, and we have a negative 1 coefficient. Next one we have x to the second, we have an x to the second, we have x to the second. These are all just different ways of writing the same thing, right? So either you could put just the x squared on top, you could put the 1 coefficient, it's understood or implied here, even if you don't write it, and you could actually push the variable off to the side and keep the 1/3 in front. So this is just 3 ways of writing the same term. Okay, so we would say the coefficient here is 1/3, and we would say the degree is second. Now I know this is kind of confusing because earlier I said it's not a polynomial if it has a fractional exponent. But this does not have a fractional exponent. This has a fractional coefficient. So it's still a polynomial if it has a fractional coefficient. It's not a polynomial if you have a fractional exponent. So if that was a 1/3 exponent, for instance, then it would not be a polynomial. But since it's a 2 exponent, it is a polynomial. So hopefully that makes sense. Oh, just really quickly, we can also go back here and we can even do what kind of polynomial. So this would be trinomial because there's 3 terms here. The next one would be a binomial. If I was more clever, I would have put it into the table, but just practice, right? Here we have 3 terms. So again, that's tri. Right here we have 1, 2, 3. So we would say tri. Right here we would say there's 1 term, so we would just say monomial. And right here again 1 term, so we would say monomial, right?